started. This is the Objective-C course, and today we're going to do something fun, I hope. We'll see what happens. It's an experiment, and is it going to be fun or not? Well, we'll see. We have up here a new item that I put in the source code examples directory of, let me show you where I got this from. Programming in Objective-C. If you click on that link, go to the last box in the window. You see Adventure Game in Objective-C. That's the one we're doing today. So it's kind of a fun thing, I hope. Let me explain the game. Actually, I'll show you the game. I'll demo the game first to you, so you can kind of see what it is we're building. And then we're going to build it all in one class meeting. So we'll see how long it takes. But lucky for me, I have it already built here, so I don't have to worry about coding it while I'm talking to you. But so it's going to be a command line game that we're going to write that's going to use functions, and it's going to use a little bit of iteration, some looping and stuff to demonstrate. And this is really just to learn Objective-C. So looking at making some instances here. And when we run the game, this is the reason why I'm showing it to you. When we run the game, it's a command line one, so we're going to have output that shows up down here. I just clicked on to run it, actually. And what are we going to get out here? On the bottom of the screen, we're going to get some text to read. So we read some text. This is what I mean by an adventure game. So as an example, the introduction kind of text says your plane crashed on an island. Help is coming in 3 days. Try and survive. So the objective to the game is to answer a bunch of prompts. And then, depending upon your decisions that you make as a user, you're going to die or you're going to survive, which is essentially what's going on. So the first thing it's going to do, and I'm just demoing it at this point, you know, the interface could probably be improved a lot. In fact, it could probably be made into a GUI, but I don't want to bombard you with GUI-ness stuff today. So it says type your name, your first name, and then press return. So I'm going to type in Barbara and press return. It says your name is Barbara. Press enter to continue. So you press enter to continue. It's basically going to give you a bunch of prompts. With blurred vision, I'm only going to go through one here. You looked around to gather your surroundings because you just got stranded. Your plane just crashed and you're on a deserted island. You're lost. The beach is rough and the salty water is irritating your skin. So you recall that the plane crashed because, you know, you just woke up from a plane crash. So you recall the plane crash. So it probably should say select an option. Walk into the jungle or sleep and regain strength before walking into the jungle. So 1 is walk into the jungle, 2 is, and the user is supposed to enter something in. So I'm going to say walk into the jungle. So if I press 1 and go return, now you're inside the jungle. So you're in the jungle and you find a bush with little black fruit at its base are white sparkled mushrooms. Are you going to eat the mushrooms or eat the berries? I'm going to eat the berries. So you go to, and the sweetness of the berries is quite savory, considering all the sweet water you consumed. Press enter to continue. So it gives you some feedback. So it's not, you don't have to do all, like press 1 or press 2. You fall asleep behind the tree. Day 1 was successfully completed. Whew. I survived day 1. So now I press return. Barbie managed to survive day 1. So I get some healthy, my total health is 110. So I have like points that I've accumulated because I made it through scene 1. If anyone's ever played a recent video game knows you go from like scene to scene and you accumulate points. Now I'm on to level 2. I'm not going to go through the whole game because we're going to see it here, but this is what we're building. We're going to build it in Objective-C. So I'm going to close this project. It's only 3 days. I'll give you all the code for it too. Don't worry about the code part of it. We'll see the code work. I'm going to stop the running here. At one point I'm probably going to go back to the project because I'm going to get tired of building it. The project itself is in that Word file. The Word file comes from a tutorial book, actually. I did not invent this game myself. The game was invented by a guy named, and it's going to come up any minute now because I've given him credit at the top, Ray Wenderlich, and his book is called Tutorials for iPhone and iOS Development and Gamers, and the URL for more tutorials is written right here. So I'm not, would like to give credit where credit is due. It is not my game design. However, I love his tutorials. His tutorials are great, and I think we're going to be able to use them to sort of put some pieces together to show classes and objects and all sorts of different things. You may also go to this URL here and get the original. I stripped, the reason why I have reproduced it, hopefully with permission. I sent him an email message, so I'm hoping I'm going to get a response back. But long story short, I took out a lot of the unnecessary stuff to get it down, and I got it down into 27 pages. It was like 60 something to begin with, so I kind of altered it to meet my needs in terms of showing you, and it's still pretty long. It probably could be shortened a little bit more as well. So if you want the full one, go to the URL, you'll get the full tutorial. And I believe he also, if you want to cheat with it, which it's not a graded assignment, it's just using this for demonstration purposes, I believe you can probably download the fully completed or even parts of the fully completed tutorial, so you can kind of like test to see if you got it right. So, but let's go ahead and crack it open and build this game so I can show you the components and how the classes work together, which is the objective here. So what we're going to do is kind of look at the model in terms of the model view controller components, the user interface, the overall logic and activity, and the data storage. So open up a brand new project if you've got a computer. I see some of you do. If you want to follow along, I'm going to try and do this as well. But I do have a finished project just in case here. So create a new project, and this is going to be of the application variety, and it's going to be a command line tool. So select command line tool and application under here, and then click on next. And we're going to leave it on the foundation as the type, and we're going to use the automatic reference counting because we don't want to do it. Why would we want to do it ourselves? So you can put a company ID in if you'd like. I'm going to call this, actually, what does the tutorial say to call it? Hold on one second. Let me make sure I call it the right names and stuff. Oh, here it is right here. My adventure game. So you may call it anything you want, really. Let me just make sure I'm doing this right. Yes, I am. Use automatic reference counting. So put in a title for your game. I'm going to call it My Adventure Game. And then I'm going to press next. And I'm going to save it to my desktop here. Actually, let me zoom out a little bit so I can see what I'm doing. Okay. And we have, just imagine everything that you get with Hello World, and here's Hello World right here. And his tutorial, the reason why it is 27 pages, well, I stripped it out to 27. The reason why it's a little bit longer is it goes from everything from like day one, which is actually not bad. And I left one part in here because I wanted to reiterate the point about automatic reference counting. So I'm going to skip through some of this reading. You may go ahead and read it on your own. I'm not going to read you 27 pages worth of information. However, it's kind of interesting to see what the before and what the after sort of looks like. In terms of what we were doing, the original main here, and it's in this, here, actually maybe I can make this a little bit bigger. Actually, I've got an excellent idea here. I'm going to make this a little bit bigger. I'm going to zoom to 150 or so. I'm going to make this 150%. A little bit bigger. We're getting bigger. Maybe I'll make it 200%. Let's see what I meant. 200%, let's see. Wow, much better. Okay, very good. Clear, too. So the original, so this is from a programming perspective, looking at the code. The original, before we had automatic reference counting, and this is what I've taught you so far in terms of the auto release pool, and a lot of the projects that we've been making so far haven't been using the reference counting. I've been turning it off so that I can show this to you. Well, reference counting, automatic reference counting came along with the current version of Xcode. So if you have an older version, you can't do this. But if you have the newer version, this is what we're looking at. This is what it looks like in the newer one. And let me just make sure it does, actually. We've got auto release pool. And then we have all the code in the middle. And we have no release pool. So you're never going to see a release. You're never going to see a retain. And what ends up happening is you'll find code samples out there, and you'll cut and paste, and you'll put stuff in. And then all of a sudden you'll go, it's red. There's a red little mark on anything that has a release or retain or a drain pool. Any of that stuff is gone. So you don't have to actually do any of your reference counting. So up here, the original one had you create the pool and then drain the pool, and we've seen this a couple of times. The nslog is just a writing to the command prompt console. This one here is nothing more than an opening and a closing bracket with auto release pool, which means go ahead, auto do everything. Just think of it that way if you want to. And then your code's in between and then returning 0. This looks like a C program to me, actually. It looks very C-like. So, alright, so that's the auto release pool. You may read through the rest of it on your own if you want to. Let's take a look at the framework. We've got main obviously up here, and just reiterate the point. This is going to be our driver program. When we make a default project, we don't get anything. All we get is main, and we could put everything in main, but we don't want to do that. It's a really bad design. So we're going to create a class, and the class is going to have a .m and a .h as we've seen so far. That's going to hold the program code. Alright, so we're going to create a new file. So usually this is kind of like the pattern you're probably going to run through when you create programs on a regular basis kind of thing. If you're going to use Objective-C. And this is the same thing for iPhone, by the way, as well. Oh, here we go. Let me show you. If the link is, and if you downloaded the Word file, the link is right there at the top. It's right. Well, to get the Word file, go to this. Go to Adventure Game and Objective-C, which is in the Objective-C subdirectory, or main part of the course. And then the first line or second line has the link there. Look through the tutorials. It's actually one right towards the top. And there's 2 sections, one on iPhone and one on Objective-C. This is the one that's on Objective-C. If you go down to the bottom of the last page of it, you can see the completed project actually. So. Alright, but you don't want to just go and look at the completed project. Although, you might want to, I don't know. Alright, so let's create a new class, and we're going to inherit from NSObject as we've seen so far. So we're going to create a subclass. It's going to be of NSObject. So we're going to go ahead and start building our application. So I'm going to go File, New, File, and then I'm going to select Objective-C. I'm going to make sure that Coca down here is actually selected. Because it's not an iPhone one, it's supposed to be. But that's the weird part. You would think if you had an iPhone or if you think you had one project type already selected, it wouldn't have you cross into the other. But it's a clear indication here. If I've got the wrong one, I go Coca Touch and I go next, right? And then I'm going UI view. Anytime you see a UI anything, you go, oh, that's wrong. So we want to inherit from NSObject. So just the same thing we were doing from our command line. We go down here, click on Coca, then click on Objective-C class and click on Next. And now we see NSObject. Perfect. We don't actually have to use NSObject. We can actually start doing GUI stuff, which is what we're going to start doing in the next couple of weeks or so, and then go from NSViewController, which is basically the same as UI view controller. It's just a different library. So let's see. We're going to call this something, and what are we going to call it? We are going to call it game, I bet. Is it name the class game. Alright, so let's call it game. So and you want to go capital just because all classes, all objects have capital letters. So game. And I'm going to put it in the same directory and I'm going to press OK. And I'm going to notice I automatically get a game.h and I get a game.m file out of that. And this is what we've seen so far. And I have the interface game, which is NSObject. So, you know, Xcode is pretty much automating the process for me. So this is much better than using a command prompt and typing it by hand. I'm going to close this window because I keep trying to switch to it. Okay. All right, so moving right along. We've made it past this far. We called it game. So now we're going to save the file to project folder. Generally, we have a project folder that is created by default, and the location comes with where we've saved it. So if we look at game.h, we see this. We look at game.m, we see this, what we just looked at a few minutes ago. Don't have to go through the purpose of this because we know this already, right? We know what they're used for, interfaces. And so if you're still kind of unclear about that, go ahead and download the tutorial and take a look at it. Okay, so we've been looking at so far NSLog, and NSLog is what we've been using, especially out here in main, to print something to the console. I've actually shown you another command called printf, and I'm just going to put that in here so you can sort of see what I'm talking about. Printf. Printf is a function call that kind of looks like nslog, but we're going to go here, this is a test as an example. And now we know we put the string in quotes, and we can essentially, and what I'm going to do is write a bad program here because I'm trying to illustrate a point. So I'm going to go like integer I. This is for people that don't have a C background, by the way, as well. And this is going to tell me I have a not doing unused variable. Yes, that is correct. So, and let's say, for example, I wanted to print this out. We already know we can say this is a test to print I, right? And then we can go, actually we're going to go %I because it's an integer. Oops, and then I'm going to go comma and I'm going to stick I in here. Oops, I, there we go. And it's going to tell me that initialize the variable I. I know I haven't initialized it yet, don't worry about it. I'm going to initialize it right now. So we're going to do scanf. Basically I'm trying to show you scanf. So scanf is the complement to printf. Scanf, for those people who aren't familiar with C, you would put in here something like, yep, %I. What else we got to do in here? Ampersand. Ampersand, yeah, I.
But we have to give in braces.
Yep, you got it down already. Okay, what does that do? That actually says give me I. So usually we put something up here that would say printf. Enter I. You can write this program for me. And then we can go scanf. And then, alright, so one of the things I wanted to show you here was demonstrating the concept here of the ampersand. So in C, and this actually comes from C, but Objective-C is right on top of C. This is a reference, actually, to the variable I. And the ampersand means the address of, for those people who aren't familiar with pointers. We're actually using a pointer in this sense, which is kind of interesting because any other time we refer to I, we don't use the asterisk or anything, we just essentially use I. If we were to run this, we're going to get exactly what is expected. It's going to essentially ask us to input I, we put in I, it's going to print out I. So down here on the bottom of the screen it says enter I, I'm going to go 12. And this is a test to print out 12. So we can kind of see the logic there. So you can use scanf and printf throughout your entire program for a command line prompt. And in Objective-C, and you're actually doing it actually works with object types as well, as we've seen with the string conversion. Well, I'll have to convert the string in this program, but that's what we're going to essentially do here. So the first goal is to enter in the name in the beginning of the program. So for purposes of that, we can get a character. So basically we've got in here the code here that's going to say, you know, contains all the guts of the, okay, so game is the class that's going to contain all the guts. The main program is going to be the driver program. So your first goal is to enable the program to receive input from the user. And I'm going to make the screen a little bit bigger so I don't have to scroll it like that. Let's see if I can do it this way. Here we go. So the first goal is going to basically give us some input. So that's what we're looking at. And I'm kind of going to explain this in a slightly different way than the tutorial is. But the tutorial goes through the concept of the scanf. And the scanf is essentially going to take characters as we've seen. Here's a C for a character. So in this particular example, we're going to use a character. Or we can actually use a number, actually, because it's number 1, number 2 kind of thing. So this one tells the compiler that it's looking for input, scans it in, and assigns it to the address of this variable here. And this is the name of the variable. So it's kind of very old-fashioned in terms of C. And it just gets character by character, actually. And it creates the dialogue for us for the input. So the first method that we're going to create is going to print out the instructions to the user. So we'll begin by providing some user instructions, which is, you know, hey, you're deserted on a strand, your plane crashed and you're stuck on a deserted island. So we're going to write a method. So in order to make the method a part of the class, we need to include its definition in the game class. So first we're going to start out with the .h file. We're going to modify the .h file to include the method that we're going to implement in the .m file, and the code's going to match, hopefully. And our method is going to look like, it's not going to do anything. It's just going to print something to the screen. And we're going to call it instructions. So I'm going to basically click on game.h. And I'm going to add the method in between the interface and the end. And I'm going to use a minus sign because the method is for the class, for an instance of the class. And it's going to be void, so I'm going to type in void. And I'm going to call it instructions. And instructions, does it take on any parameters? It does not. Okay. I know, I just wanted to make sure I was creating it. If I had in some parameters, I'd be putting them next. But in this particular case, there's no parameters, so it's just void. I'm not going to really take, well, it's not going to return anything, but it's not going to take in anything either. So then now I can click over to the, this is in the .h file. Oops, I'm sorry, am I in the wrong file? No, I'm in the .h file. So this is the interface of the particular method that we're going to implement in the implementation in the .m file.
In .h file, normally it's
This is very good. I like this. Yeah. No. Keep asking. Yeah.
Bracket. Outside the brackets we give the methods. Inside the brackets we give the variables. So you have to give empty brackets before you give the method.
Oh, not for a function prototype. Think of this like a function prototype in C++, where we've got essentially in what we're doing is in the interface we're creating the prototype for the method that we're going to implement in the implementation file or the .m file. But this particular case, it doesn't take on any method. It's not taking on any parameters, so we don't have to put any in.
Okay.
So the function actually just sort of looks like this, and it's outside of the opening and the closing. That's what you're talking about. Excellent point. We don't even have to put it in if we don't have any, which we don't have any. But if, for example, let's just do this just to reiterate your point here. This is where variables would go. If we had variables, which is different than C++, different than Java, different because only the variables go in here, not the methods. Methods always go outside. Yeah. Which is different. It's very good. Very good.
So
yeah?
If we are not giving the variables,
we don't need it. If we're not going to use it, we don't need it. Opening, closing brackets. Yeah. That's why. Well, I'm going to leave that in there though, because I believe that this has it in there too. Instance variables. Yeah, there we go. All right, so we can read through. Here we have the opening and closing brackets. This is where you're going to define variables that are specific to the class, yada yada. And now we have the data type. We remember this is the data type, and this was just of the return, and there's no return. It's not going to return anything. That's why it's void. The minus sign is going to denote that it's an instance and not of the original class. And then in contrast, we can put Boolean in here. It's going to go through all the different data types and the usages of that, essentially. This is why it's 27 pages long. All right, so let's take a look at the .m. So the final .m file, well, let's see what we got going on here. This is the implementation. So in the implementation, that's where we're actually going to create the method body. So out here on the .m, some people would kind of go like this maybe and copy it, right? If you wanted to, just make sure you had the same thing. Because believe it or not, like in the iPhone API, and it actually does it for you. Puts the blank implementation in there for you. But what we have here is instead of that semicolon at the end, we have our opening and we have our closing brackets. And what we're going to do in the .m is include the instructions, include what it is we're going to print to the screen. This is the implementation of that method. So this is where we're going to have the opening and closing brackets. We're going to have everything set for us. So stuff you want to put in the method. So we basically created the method template for us. And if we're working, again, like if we're working with the iPhone, it's going to do it for us automatically. Actually, iPhone and iPad does it for you automatically. Okay, so now what we're going to do is we're going to go out to the hello world that we have created out in main, or actually it was given to us automatically. If you remember that code, it says hello world out there. All the mains say that. I guess, so your program will run as soon as you create it. And And we're going to comment out the above, and I'm going to actually kind of do this so I don't have to type. I'm going to put this in there instead. So number one is initialize the game and then show the instructions. So what I'm going to do out here in my Xcode project is I'm going to click on main, and I'm going to get rid of all the stuff I just put in here actually, because we don't need I and printf or anything like that. So I'm going to go ahead and delete that stuff. And let's see if this paste works actually. My game. Well, let's see. Let's see what this says to us. It says use of undeclared identifier. And we're going to go, why is that? I know, hey, you're giving it all away. Why is that? It doesn't recognize it. Okay, so we have to import game. No, actually, you can. Actually, you know what? Go ahead and do it. Go ahead and do it, because actually, you know what? That tells me you actually know it. So yeah, I know how much detail I have to do if you're gonna blurt out all the answers. Oh. No, but go ahead and do it, because that's great, because I like the interaction, because then I know what people are getting and what they're not getting. So go ahead and ask questions and blurt out answers. It's actually kind of cool. You're taking the fun away from me, but you know. Alright, so now we have, and make sure you keep the auto release opening and the closing. Kind of just think of this as an extension of the main function. In fact, you probably just saw what I just did a few minutes ago actually. I kind of did this. I sort of tried to make, in fact I probably should have done that instead. I put the opening bracket way up here, and then I put the closing down here, and I kind of made it so I didn't actually start on the first line. That way I'll never actually accidentally get rid of it. Alright, so what did I do? We've seen this code before. We made a new instance of game, and we ran alloc on game. Even though we have the automatic reference counting, we still have to allocate. We just don't have to deallocate. And then we ran init, which we've gone over already for the initializer. And our new instance is going to be called myGame. And then we're going to show instructions by running myGame instructions, but we don't actually have any instructions. So we probably could have gone property. Well, no, that would be on the variable. So let's go back to the instructions here. So now we have a instance of the object created, and this is going to go through everything I just went through a second ago. And we could actually build and run the program now to sort of test it. And if we build and ran it, let me just do it just because I want to make sure. Not a bad idea to actually build and run at different points, because then at least, and we're not going to get anything, so nothing's going to happen because there's no output. The program just stops. So nothing's going to happen. On some of the older versions, we had this kind of thing that showed up on the window. It was a debug mode. If you have the debug output screen showing, I just closed it actually. I have a habit of closing those extra windows I don't like. Then you'll see the debug information, but in my case I'm not going to see anything. You might not see anything at all. So now we're going to go back and build some functionality. And so we're going to introduce the game scenario and ask for players' names, which is that first step. So we're going to be able to use our Scanf. So go to the first step is to print out the message to the console window within the curly brackets of the instructions in game.m. So insert the following code. I'm actually going to cut and paste here and then modify it a little bit so you can have time to actually do it yourself unless you're doing it. So game instructions is going to need to do something. So when we go game instructions, we're going to go to the game.m file. I'm no longer going to be using .h anymore. It's always going to be in .m. And now I'm going to stick this first line of code in here. And this first line of code is going to show the instructions. I could use a printf if I wanted to. If I'm using a printf, it's going to do the same thing. But this is Objective-C, so let's start using nslog. nslog prints out. So this is where we're getting your plane crashed on a, I'm going to modify a deserted island. Deserted island. Help is coming in 3 days. Try and survive. The /ns we know are line returns. And I didn't like that. I didn't like the way it looked before because I'm going to put a line return at the end. So you may change the code so it says whatever it is you want it to say. Now if we run it, we know it's working because we should get this printed out on the screen, and we have it printed out on the screen. It says your plane has crashed on a deserted, I probably spelled that wrong, island. And here, let me take out the word deserted because I know I spelled it wrong. And then we're going to get a line returned, and I can see the line return now in the end. So your output, your initial output should show to the screen, hopefully. If it doesn't, take a few minutes and figure out why, if you got an error message. If you download this file, you can just cut and paste like I'm doing as well, or you can just type it in. But the syntax is essentially a little bit different than printf. Actually, something to note. And I'll only say this once, actually, as I go through and stuff. As we've seen so far, this @directive basically is identifying this as a string, which is kind of weird. It's telling the compiler, hey, I got a new string for you. So if we had I out there or something, I could go, @I. I go at just the same thing as I do with the printf. I can do with the nslog. Actually, I can print out stuff. Okay. So let's see. /n is going to give us our line return. So now we're going to basically ask for the user's name. So before we can actually ask for the user's name, we have to define it. So we're going to define the storage for name, and so we're going to create a character array and call it first name, because we're not going to use the string class, because that would be like way too C++-ish. So instead, what we're going to do here is define a character array, and the character array is called first name, and it's going to hold 20 characters. This is equivalent to a string, actually. We can convert a character array. Character arrays are a little bit easier to print to the screen than NSString is. And if you watch the video from the iPhone class a couple of weeks, or maybe one meeting ago, we converted strings to numbers and then back and forth. You see there's a little bit of conversion. It goes into the form of C strings, usually, which is equivalent to a character array. So, okay, so the above code here created the array of characters. The word character denotes that it's a type variable. That's the variable type, and the name of the variable is first name. So a string is a character array, actually. Alright, so back to the code. The 20 indicates that we can hold up to 19 characters, because we're going to start the array out with 0. And so now we're going to do a scanf. So I'm going to cut and print this in here, because we're just doing this sort of line by line. And alright, so if we wanted to, but we're not going to use we're really not going to use this until we're not going to define this until we need to use it. So there's other different ways of designing this, actually, to take this out of this method, make it global or something if we wanted to, but let's not worry about that actually right now, because we're going to see how it's going to be used anyway. Once it's used in the class, in the object, in any of the methods, it's already, and it's going to be referenced from the object, so it's automatically going to be visible, so we're not going to worry about that. So remember this scanf that we saw a few minutes ago when I first started out the lecture. Scanf, and here I'm using an S for the first name, and I'm calling it, I'm going ampersand, as you remember before, to go to the memory address of first name. S stands for string. This is equivalent to a string, but I don't have to include string.h, and I don't have to go string first name, which is essentially the equivalent. So go ahead and add your scanf in there. Make some room underneath it. So now we have the name. And this is going to go through what the name means, yada yada. So all we do is convert. So we're going to need to create an NS string for name to convert the scan. Okay, cool. Scanf doesn't work with objects. Scanf works with variables. So we create a string equivalent variable. We convert the variable into an NSLog object, which in the object is going to be an NS string, which works with NSLog. Which is interesting. So our string would work with printf, but if we want to use the nslog, then we have to convert it. So we will convert the C string to an NS string, and then the nslog will log it appropriately. Note that the NS string is actually an object, not a variable, so we're using object-oriented programming. So the next step here, and I'm going to kind of cut and paste this and put it in as well, is to take the character array and convert it to a string. So, and you can actually just type the code if you just want to take it from here. So NSString name is equal to NSString with C string first name encode, and then encode as ASCII string encoding. So we're taking the string, we're running a method to string with C string to create an NS string out of the string with a C string. And the C string that we're taking in is called first name. And the encoding of this first name, well, we know it's in a string encoding for ASCII. So we created the NS string. And why did we do that? Because we wanted to use Scanf. If we didn't use Scanf, well, you know, it wouldn't be interesting if I didn't have to show you, if I didn't show you any of that. So if we didn't use Scanf, we don't have to use. We can just, you know, use another technique. So how can we use another technique? Well, we could take an object, take a property of an object and assign it as a value or a property to another object. So if we're creating this into a GUI, and it might be interesting to create this as a GUI, maybe for Wednesday. I have to put it together because I won't have it, but it'll be a different tutorial. Well, I'll take the same thing, make it into a GUI. It'll be interesting. We could take a .text attribute from a UI object that's on the canvas, and that's an object to an object. So there's no conversion. But sometimes you want to be able to use scanf and printf and stuff like that. Okay, so enough of that. We convert it. Now we have NS string, and this is a pointer to name that we're going to use. So we can create name as a pointer, and it can be assigned to the value of your C string converted, which is what we use, the string with C string conversion. So now we're going to go back and take a slight alteration here to increase the ability to reuse the variable name. So because it's declared as an NS string, it's located in the instructions method. Remember we just put that, as I was talking about before, that's one way of doing it, to put the stuff inside of the method, but it's inside of the method. We want to make, throughout the entire program, we want to make this string visible. So we're going to create an instance variables, and in the instance variable is going to essentially do that for us. So if you declare name as a variable for your game class, then you can use it anywhere you want. So remove the declaration from the instructions method and add it to game.h. So simply cut the first line in section number 4 and paste it into game.h with the curly brackets as follows. So, you know, we're going to take this here, and so what we're going to do here is pull it out of here. Actually, I'll just do it this way. Cut it out of here. This is visible only within this method here. Go back to the .h file and put it in here. These are where our variables go. So we put it in here. Oops, we get rid of this one here. Put this guy down here. There we go. Now we've made this visible for the entire object, not just in that particular method. So, which is not bad. And then now here that error message would have gone away, and it did go away. So now we have name. So just like Java, just like other languages, but knowing that we don't have to redeclare it, we don't have to do anything else in the .m. Now it's visible for the entire life because we're going to use the name everywhere. Yeah. Barbara, you died. Barbara, you did this. Barbara, you did that. So now if we compile and run it, we know it's going to work. It's going to give us the message. You know, try and survive, enter in your name, all that functionality should work. I'm pretty confident my functionality is going to work, so I'm not going to compile right now, but if you're bored, you can compile yours. So now we're almost done with the instructions method. So we need to give the user some feedback. So when we take the name in, we're going to print it out. So step number 5 of that instructions method is this line of code here. And in instructions, we have to go back to, and actually I'm here already, and I'm going to leave these numberings in here. And I'm going to paste this guy in here. So now number 5 is display the name. So nslog your name is, and then this is the interesting thing. So as remember I said before, nslog can pretty much do the same thing as printf can in terms of printing out with the, and the key here is this $sign, or excuse me, %sign. But the object has a object value. Excuse me, it's an object data type because it's at the @directive. And remember before I created this @object, I called it an it's actually called an @directive that creates this object that's going to be sent to nslog. So pressing a key here, we can put name in here. Anytime name shows up, anytime a string, an ns float, an ns anything show, actually we don't have ns floats, but anything ns can be done this way. So we can print out the value. This happens to be a string, so it's going to print out correctly. We're not going to get like some ASCII code. So this is going to say your name is such and such to the screen. So that's how we get, the feedback that we're going to do. So note the absence of the ampersand. This is why I like this, because I can point stuff out. Name is an object already, and so it's already a reference. Yes?
Percentage is set, ampersand is like if there's an integer or a float, everything is ampersand.
Yep. This is this could be I. That would actually work, but actually take this out. But if we were doing that, then this would have to be an I. I mean, it would have to be an integer type. If it's not an object, it takes the ampersand. It takes this ampersand symbol. If it's not an object. If it is an object, there's no ampersand symbol. And the object with the @ symbol, is going to denote that it's an object. Yeah. But it's always the percent sign. Well, how did they come up with a percent sign for that? I don't know. But it comes from the printf actually. So NS is kind of like the object-oriented version of it. So name's already a pointer to an NS string, so there's no ampersand. So we reduce the redundancy of @name, the address of name, because name is the address. So we compile and run it, and we're going to see essentially the information being printed to the screen correctly, hopefully. So now we're ready to develop the better framework and develop our plot and put our game together. So more framework stuff. So we can already successfully enable the computer to receive input from the user, although we're not entirely finished with this task. The next goal is to allow the user to restart easily if they wanted to. And when they approach to solving the problem, you can write essentially, you can go, user enters name, proceeds through the dialog, blah, 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 die, try again, blah, blah, blah. Or we can create a loop. So we can go one line by line by line, all the different scenarios. Or we can click and realize that a while loop would be a tool to run the same statements over and over again, perhaps. So we're going to select the main file now. We're going to get our code for the loop that's going to be running the program that's going to continuously ask for input and proceed forward, ask for input and proceed forward until we get to the end. So we're going to select main.m. You don't need to initialization of your game to be repeated. So you want to create a while loop that's going to be composed of section number 2 down here, while leaving section number 1 outside the loop. So replace section number 2 with the following. So let's just cut and paste this actually. And let me show you what I was talking about here. So our original program, our main, had this guy in here, and this guy for section number 2 showed the instructions, but it's just going to show the instructions and it's going to stop. So instead what we're going to do is create a loop, and the loop is essentially running the second part. So I'll leave this here for a second. But now we have a Boolean, which is a new variable that we're going to put in here, and the Boolean is going to say game is running true, and then while game is running, while it's true, this is the instruction here, which is number 4, that replaced the old number 2 that we had. That's essentially going to run our game for us. So I can remove this guy now, because now we have a loop that's going to be running. And also notice we have this opening and closing bracket for the loop as well, if you're not familiar with while loops. And so this is, anything can be put in here, while x is less than 1, but or something like that, a control check, as long as it equates to true or false at the end of the day. So this one's going to give us true or false. In fact, sometimes you'll see just people go like this and go true, which is legitimate, while something is true. But how can you change true? Well, we can change the value of this Boolean, so I'm going to go ahead and undo that typing. There we go. All right, moving right along. All right, so here's a step-by-step breakdown of what we just did. Okay, I just talked to you about that. Okay, so now what we want to do is want our users to be able to exit the loop and end the program. So this can be accomplished by prompting the user for a response, and we want to proceed forward with the instructions. To do this, we need a variable to store the response. So we add that that follows section number 1 in main. Right after the initialization of the game, we're going to add initialize response, so init response, which we're going to create another variable that's going to keep track of the response that we're getting. So we can put it here, we can put it up here, actually let's just put it here. So now we have init response, and response is going to be, do you want to continue, yes or no? It's going to basically be our input for our response. So now we get the user's response via the following block of code, which should be added to the main.m file directly below section number 4. So this is going to be our quit. So right underneath section number 4, we're going to put this in here. So now we have section number 5. So here's section number 4. That's going to say, here's our while loop. And let's see. Let's put this inside the loop, actually. Because if the loop's going on, we can't stop the loop. So otherwise the code's never going to be reached. So if you start this loop and we're checking for true, how is response ever going to change? How is anything ever going to happen? So restart, yes or no, is going to tell us if we put in, we're going to scanf for the response, and then if the response is equal to 2, then we're going to break, because 2 is no. So 2 is no, 1 is yes. So this should show up at the end of each one of the turns, because it's at the end of the is game running kind of scenario. And I believe, let me just check my instructions, but I believe that's where it was supposed to go, actually. Well, we'll find out eventually. If it's not supposed to be in the loop, we'll find out eventually, and I can move it around. So let me just make sure real quick here, actually. Add that to following one right after the line initializer. We did that one. Add it to the main directly below section 4. Okay. First, try and understand the above means. Okay, so the NSLog provides the users with the guidelines for the valid input. Then the scanf prompts the user for the integer that will be stored as a value. And then if the value is okay, it quits the program. So you can actually, actually it's going to do it. So if we run the program, we should see the desired response. And this is actually not a bad time to run the program, actually, to make sure that we have that done correctly. So type the first name and press enter. So I'm going to go Barbara, press enter. And this is the response that I'm looking for. So I have put it in the correct spot. I put it in the loop that's going to be essentially running our program. So it says Barbara, adventure game, restart, yes or no? I'm going to go no, press 2. And my program should have ended, and it does. So we know that that behavior is correct now. Alright, so let me go back to the instructions. You may optionally leave that out. Your user will not be able to immediately restart. So as you run the code, you ought to notice that there's currently no way for the dialog to wait until the user has pressed an enter. Well, that's true. So to solve the problem, we're going to use a helper function to hold the dialog so that the user can enter something in, which is kind of interesting. Actually, let me check on something real quick, because now I'm kind of curious. Kind of curious if the instructions were supposed to put that. I would have put it inside the loop, but let's just see real quick, actually. There's a quick way of telling. Let's see. Let's go to main. And response, game running, healthy printing. No, it's inside. It's inside the loop. We put it in the correct spot. Okay, I just wanted to make sure. I probably should change that so it's a little bit clearer. But we have it in the right spot. And I hope that my adventure game, here we go. I was going to say, I hope I just saved what I was just doing. Okay, very good. So we do have it in the correct spot, by the way. So we're going to continue forward, and we're going to create this little helpful function that's basically going to allow us to wait for user input before we proceed. So as you might have inferred, you're going to be able to create a function that will truly help in the program design. Like the instructions method, we're going to create another one. So to begin, we're going to declare a function in game.h, and we're going to define it so that the definition can be imported, like in the game class. So note that the declaration will be in the game.h, and the function will actually be independent of the game class, so denoted by the @ interface. So your function will be called wait on CR for carriage return. Wait for a carriage return. So you enter something in, it's going to wait for the character return. When it does that, it's going to continue. So it's going to help us with our user input. So here the wait on CR declaration, aka its prototype. Place it above the game class definition. So above the interface, because it's not going to be part So I'm going to cut and paste it. I'm going to open up game.h, and I'm going to put it above the interface declaration. So game.h, and I'm going to stick it right up here. We're doing this because we're writing a function that's going to work independent of instances of objects. It's going to be run from main, and we have all these instances of objects that are going to run, and occasionally we're going to probably after every turn wait on the carriage return and strip it out, or do something with it, because when we enter in a string and we put a carriage, we're just going to have a carriage return at the end. So we can use it for multiple purposes actually, but it's not really part of the object implementation. So, but we can put it up here, and this is just like an old-fashioned. This is extremely old-fashioned. This is C. This is a C prototype. This is a true definition of a prototype actually. So, if you think about the concept. Okay, so we've put that above the interface located in game.h. So the first void indicates that the function is a void return type, doesn't return anything. We already know, about the name of the function. We have so here's the wait CR implementation. So place it above the main function and below the two imports inside of main.m. So we're going to implement it in M. It's not part of the main function, however. It's just going to be an ad hoc function declaration that we're going to run inside of main. And this is very C-like. So below the two imports, above the main function. So we're going to go to main. So we got our two imports. Here's our two imports. Here's our function. Why do we put it up here? Actually, you can answer that question. Why do we put it way up here? Why do we put it on the bottom? Okay, we put it way up here because this is old C style. If we don't declare it first and we use it inside a main, it's not going to know where it is. It's not going to know what it is. We could do a different style. We could put this in a separate class and call it like my generic functions. Or we saw a category, another word for it. So we can essentially create a separate, or if it's just one function, which is this is just one function. If we had like a dozen of these functions, probably going to stick it into a separate category. And did we see categories last time? Or was it? I'm confused with this class and the iPhone class. Did we see that? I think we did actually. We went File, New, File, and then I'm sorry, I'm calling it a category. It's a protocol. And then we went next, and then we give it a name. It creates a single class without a .m.h. In fact, it's like the old style header files of C. It just, actually the protocol is going to create the templates for that we can implement sort of like an interface. Then we can create categories, which are just, actually I'm calling them categories because that's the iPhone term for it, but it's just a class object that's not going to be used as an object. It's just going to hold these things, like this particular function declaration as an example. And then we're going to import it in, and then it's almost as if we just wrote it right here. So we're bypassing that because we only have one function. So hopefully that makes sense. So the function's outside of the scope of the class. It's not really part of the class implementation. And what are we doing here? We're doing a while loop, and we're using a get character. And what we're going to do is, well, it doesn't equal this one, which means flush the line buffer, because while we're going to get rid of the line return. So when the user actually presses 1 and then return, we're going to get the output actually looks like that. So we just want the 1. So we're going to take the second character away. So it's going to flush it. So it's going to get rid of those. So it's waiting on this line return. When it gets the line return, it stops getting the characters. So, well, it doesn't equal this. Flush it. Okay. So that's coming in handy for us. But it also demonstrates and gives you the opportunity to demonstrate a function that's not a method. It's just a regular old function. And we had to create, because we put it in the game. Actually, I'm sorry. We put it in main. Where did we put this in? Main, I hope. Main. Yes, good. We put the function prototype in a totally different area, though, which is kind of interesting. So, all right. We put this one in game.h, and we put this one in main.h, main.m. Okay, so now this is going to go through all of the different, if you didn't understand what I just went through a few minutes ago with the get character, this is going to go through all that stuff. So, okay, so now we're going to add this function call to main. So what we're going to do, so for now it's time to begin with the wait on CR. So you've noticed earlier the user never gets a chance to press enter after the log. Your name is such and such. Press enter to continue. So all you need to do is update the instructions method to include a call to wait on CR. So I'm going to just kind of cut and paste this and put it in the instructions method. So I'm going to go out and in the game.m file, I'm going to make this one here and number 6, and I'm going to call the function call. Which is kind of weird because the function, it's all within the same scope because we're including game.h inside of main.m, which means we get the prototype for the function. The implementation is in main. The function call is in game.m. So everybody's aware of the function. It's within the same scope. The implementation is in a logical spot. You know, obviously you could probably play around with that a little bit, move it out if you wanted to, but it's kind of interesting how it's kind of another realization about the scope of all this too. It all is within the same scope. So all this is going to do is wait, so it doesn't like continue after a person puts their name in, and so it'll pause between each one because it's going to strip out the line return. I used to explain this in a C class as when you enter in one character and you get 2, it skips ahead, stores it in a buffer, which it does actually. So when you type in 1 or my name and then return, I actually have two items instead of 1 item. So that kind of wait on the character return gets rid of that a second item for us. Okay, so now we're going to add some properties. So properties are the concept of the object-oriented classes in terms of the implementation, where we have attributes, and these are attributes known as properties. So in Objective-C, we have property values that are stored in instance variables. So we're going to have to keep track of points, health points, things of that nature. So because the methods are repeated, nearly identical for most properties, we're going to use synthesize and property to declare our variables, which we've seen already. So now properties have been declared and synthesized. If we create properties in terms of the automation, we can do them automatically is what this is basically referring to. So for example, if we have my game.health is equal to 25, we're going to store the value of 25 in this particular property. So add the following line after the closing bracket, after the closing curly bracket and above the void instructions. We've done this before actually. We're going to create the property and use synthesize. So in the .h file we put the property, in the .m file we put the synthesize. So this is going to be above the, well, we usually put them at the top. So we're going to go into game.h and put it above the method that we've declared. So here's our method. And I'm going to paste it in here. So I have property, and my pasting doesn't put my line return in. So I have property strong, nothing more than essentially creating the NSString name in the .m files where we're going to add synthesize. We're going to put it kind of in the same spot here. And actually I can just cut and paste the instructions. So you'll notice that there's the word strong is in there. To explain strong for you for a second here, it's defined exactly the same as the instance variables located in the code. So when we said character array, my character array 50, it's basically the same kind of thing. Strong refers to how long it's going to be stored in memory. So strong means it's never going to go away. Weak means, well, if it's garbage collectible, collect it. So iOS5 has new automatic garbage collection, as we've seen so far in memory. So the compiler automatically determines something should be deallocated when it's ready to be deallocated, because we're not doing any deallocation. So the parameter strong explicitly retains it into memory and prevents it from being garbage collected. Why do we want that? Because the name of the person is going to be used throughout the entire program. If it gets garbage collected for some odd reason, because we don't have any control over this, then we're going to lose the person's name. And we don't want to lose the person's name. So basically we're just saying keep it forever. Don't get rid of it, which is strong is basically. And weak is going to do the exact opposite. It's going to say, okay, just let go. If you leave out strong and weak, it's weak. So automatically goes back to that. So the parameter strong is going to say leave it in memory. You notice that none of the parameters you created for this game will have a parameter. None of the properties will have a parameter. This is because name is the only pointer to an object. Okay, so that's all right. So now we're going to continue forward, and we're going to put the word synthesize name. We're going to put it in the .m file, and we're going to put it right below the implementation line and right above your first method definition. So if we go back here, and we are in now, I hope, game.m, right below implementation, right above the first method, I'm going to put in here synthesize, because we know those comes in sets. We have property in the .h, and we have synthesize in the .m file. So I have synthesize name. Perfect. And keep maintaining good coding practices in this tutorial. You're going to look at instance variables and properties. I recommend using a line property directive, but synthesize can handle them all in one separate line. We could say synthesize name, score, health, etc. all together. What this is basically saying is that we have choices in terms of how many properties we're going to string on one line. Usually you'll see, it's kind of like saying integer I, a semicolon, and then underneath it, integer A, semicolon, integer B, or going integer I, comma A, comma B, comma it's the same concept essentially. Usually, you know, it's up to you whether or not you think it's easier to read or not. So, okay. All right, so let's start with the main game structure and the strategy. And main idea is it's a text-based basic survival. So we're going to have things that are going to keep track of the number of days, because we have 3 days that the user is actually going to be alive, hopefully, at most, if they make it through that part. So we're going to declare day 1, day 2, and day 3 located below the instructions declaration in the .h file. So we're going to create these methods that are going to determine the behaviors for each one of the days. So I'm going to cut and paste this actually. I'm going to copy and put it in the .h file. We always start with the .h, then we move to the .m. So right below the instructions here, I'm going to load in I'm going to paste it in here, day 1, day 2, day 3. And we could be a little bit more creative. We could put spaces in between. Doesn't really matter. So now that I have my function prototypes, I can go out and add. And this is kind of not a bad way of doing it, actually. Just kind of add into the .m file the implementation. So you're essentially putting in the. I think I just clicked on Eclipse accidentally. I did. I have to stop clicking. Let me just get that out of the way once it gets up here. Why am I in this file? I don't know. I should be in game.m. And then underneath the instructions method, before the end, I'm going to paste this in here. Now what I've just put in is the function declaration without any bodies. And this is the .m file. Get rid of this that's running here. I accidentally clicked on Eclipse. I apologize for that. Okay, good. So now we have matching. So if we wanted to, which is probably not a bad idea because it's been a while since we compiled it, but we should probably compile and run it just to make sure. But I'm not going to. But if you want to, you may do that. So now you need to add the ability for the player to die. So if he dies during day 1, you don't want him to go on to day 2. Because he's already dead. So rather you want the user to respond to the restart dialog instead. So you need to create a condition where the player is going to enter into the next day only if he's alive. So you're going to create a Boolean instance variable called user is alive and locate it below the name variable that we created in game.h. So I'm going to cut and paste this and stick it in name.h. And excuse me, game.h. Underneath name, I'm going to stick this guy in here. And This guy in here says Boolean user is alive, which means if he's alive, then continue. And if not, then don't go. And then add the property declaration in game.h. So we're going to add the same thing that we did for name. We're going to just do real quickly for the other variable that we put in here. So underneath the name, and actually I'm just going to stack them one underneath the other. So I can, go here, paste. So and then, I'm going to have to put the synthesize in, right? So I'm going to go over here. And so instead of putting the synthesize in all on one line, on different lines, one right after the other, I'm going to just go here, comma, and I'm going to go, actually I'm going to paste it because I don't remember what it's called. Yeah, there we go. Is user still alive? I could essentially go back to the .h and do it, comma, Boolean is he alive on the property as well. But, so I added another variable to keep track of that, and I put the synthesize in the .m file. So for each day, now you need to figure out a check at the beginning to see if the user is still alive. If they're still alive at the beginning of the day, then they can continue. So we're going to create a loop for this, and we're going to put the loop inside of each day method. So we have 3 day methods. So for day number 1 is unique because the user should always be alive on the onset of the first day, hopefully. You haven't arrived, unless you died on the plane, then you're not necessarily alive. So at the beginning of day 1, set the value and user is alive to true for day 1. So we're going to put this in the beginning of day 1, so in the day 1 function. And we're putting this in the .m file because this is the game. So in the .m file for day 1, we're going to say this here. We're going to say user is alive is equal to true. Okay. And now we're going to add the following code to each one of the day methods. In the case of day 1, the code would go below the line we added above it. So I'm going to just go like this here. Copy. So we're going to put this one in each one of the methods to check to see if the user is alive. So in here, paste. And while user is alive, statements for the day are going to come in here. In fact, we should do that for the first one too. We have 3 days total, so go ahead and put that in the first one too, actually. Because we're making him alive on the first day, and then while he's alive on the first day, he's going to do something. So. All right, we're almost done, believe it or not. I knew this was going to take the entire class, Ray, but I didn't. Okay, so now that the day's statements need to affect the user's character in the game somehow in order to see what his status is. So we're going to have a variable for health. So for example, kill the user, slightly benefit him or her, or slightly hurt him or her, depending upon the status. So for this to happen, we need to create a property called health and add the instance variables. So go ahead and add integer health to game.h. And then we're going to have to add the properties, and we're going to have to add the synthesize. So here's game.h. And I'm going to put them right here. We got another one here. We're going to solve this integer health. And you know the drill by now. In fact, it's probably just easier for me to type it at this point. To cut and paste it. Property. I'm going to go strong. It doesn't really matter, actually. Health. You know what? I'm just going to go here. Health. Oops. Health. Oh, you know what? I don't have to for integer. Ah. Let me just make sure. What have I got going on here? Integer health. Add next add the property declaration to .h file. I do. You know what though? I don't think I actually have to do it for integers, but maybe my syntax was incorrect. Oh, okay. Oh, integer, you know what? I left out the data type. Yes, thank you. Yeah. Okay, I'll cut and paste to make my typing better. Oops, I have 2 semicolons here. I don't know how that happens. Can I just do this then? Yes, I can. Okay, very good. All right, so we have the synthesize and we have the property. Let me speed this up a little bit so I don't run out of time. And so now we've added the synthesized health. So note that the health will have a numerical value associated with it. It's not actually an object, but we still get a get because it's an integer value of health. So we're going to make a property use, we're going to make it assign to 100 because it needs an integer value for day 1. So add the following code to the end of section number 1 in main. So in terms of section number 1, I'm going to copy here, add the following code in the main.m file because we need to initialize this here. So here's initialize the game in section number 1. I'm going to put in here paste. MyGame.health is equal to 100. So we added, it's just going to set health because of the property in the synthesize. So we were able to set the value to 100. So we're going to start at 100, we're going to go down, or we're going to get healthier depending upon what we do. So the above is the starting health for each one. And okay, so also we have to keep track of the answers that people are typing in. So for every scanf call, the user is going to input needs to be stored in terms of a variable. So for this, we're going to create an integer instance variable. It will always be 1 or 2. We're going to call it ands, and we're going to put it in games.h. So I'm going to cut and paste this in here, and then we're going to have to do the synthesize and the property for the ands. So I'm going to come back up here into game.h. I'm going to add in here, paste. And then I'm going to, okay, I'm just going to do this. Just to make my life easier. And then I'm going to go back up to the .m. I'm going to add ands in here. There we go. So now we have ands for the answer. It's going to keep track of the user's answers. Okay, so the next bit of code that we're going to put in here is the boilerplate method for all 3 of the days. So day 3 will be a difference at the end because it's the end of it, end of the game. They don't go they go from day 1 to day 2 to day 3, and after the third day, the game's pretty much over. So you're going to copy the comments below into each one of the day methods. Wait a minute, we have a, do you want to do it now? Okay, hold on a second, let me just pause this. Okay, I'm ready to get back to this. Okay, we're going to finish this up. Okay, so what I've done is actually opened up the solution so I don't have to go through at the same pace. So I'm going to pick it up a little bit because I want to finish this today. But, okay, so the next bit is we have to put the scenarios in for each one of the days. So day 3 is going to be a little bit different. So we're going to cut the comments below and put them in by replacing them into section number 2. Replacing the section number 2 with whatever, replacing section number 3. So we're going to cut and paste and put in, and all the code is given to you here. But if you go to the website, you can download the completed one, and you can actually kind of see how it comes together. Lastly, we're going to want to execute all the 3-day methods. So although they haven't been defined yet. So in terms of main.m, we're going to go my game day 1, my game day 2, my game day 3. So let's take a look at. I'm going to jump ahead a little bit and look at the finished main.m and see what we're going to add to it. And I'm going to explain this in a little bit different fashion by showing you the big picture. This is the solution. So it's got a little bit more in here than what we had. We almost got to the end, however. The next step that we were going to do here, we have our function up here. We got this far. We got all the way down here. We have our while game is true running. We put in our health. This is where we stopped actually. We ran game instructions. So the next thing we're going to do is run my game day 1 because we want to run the method for game 1 to prompt to the user everything that the user is going to read and then say yes or no. And then after each one of the days we're going to print out the health status. So at the beginning of the class I sort of ran through that and you saw, hey, I'm still alive. And my health was 110 actually after day number 1. I don't know how I did it. I guess I selected the right option. I didn't eat I ate the berries instead of the mushrooms. But yeah, don't eat the mushrooms, I guess. But so what I'm going to do here is proceed with day 1 and then print out, well, run the method. So what you're going to get here is practice running methods is what this is all about. So, and then day 2, print the health method, and then day 3, print out the health method. It's a kind of redundant. You probably, there's probably easier ways of designing this. And then we're going to put a check in here to say if the game.health is less than or equal to 0, that means you've died. So this is in our big loop. in our big loop that's going on while game is running because we've decided not to quit. Inside we have, towards the end here, we've got this kind of loop here that says, you know, you have died. Please enter for the next dialogue. And then we're going to run this here at the end because instead this is going to actually be in here at the end. And we'll see those methods implementations in a few minutes. But we have a check to see what the health is like because at any one moment if the health is smaller than or equal to 0, we're ending it early. So we're going to print out this message to the screen. And then we're going to go my game print score. And we're actually sending it the score of 36, which is I guess the lowest we could get in this particular game. And this is just nothing more than it's going to print out some end results. And the end results are going to give us the status of the game. So this is the same thing we had before. In fact, this is the same code. So what we filled in next for the code is the game activity. So let's take a look at the game activity. The instructions are going to be a lot longer, so I'm just going to go through it this way for you. If I look at the game.h file, this is exactly how we ended it. However, I added on now, we didn't get this far actually. We have print health and print score. Print score is taking on a variable parameter, which is a value float. And remember, we sent it 36 from main, so it's going to print out 36. So, no, you know, I'm sure there's some logic behind that. This up here, I probably could take out and the game would run. The end definition is to eliminate multiple include situations. So when you have included the same include file in multiple classes that are inside of your project, your compiler is going to give you an error message. In fact, I believe I could probably pull that out and you're not going to need it because it's not, although it shows up in the solution file, it's not part of the tutorial, so it doesn't really matter if that's in there or not. So the .h, we just added these two, print health and print score. So in the .m file, if you read through the rest of the instructions, what you're doing is you're printing out for all of the sections. We already know the top because we've already completed this part. This is the part we've already completed. So day 1 as an example, and then all the days are going to look the same. We have our is user alive up here, which we put in. While it's true. Then we have scenario number 1, answer number 1, scenario number 2, answer number 2, and I'll just go through one of them here. So it's printing out a bunch of stuff to the screen, and it's saying Scanf, and it's going to print in the answer, and then wait on calling our method to our function to get rid of the line return, and then it goes on to number 2, and it looks at the answer. It says, well, if answer is equal to 2, then do something else. And then you're going to set your health. So I guess 2 was the wrong answer. No, you feel well rested, however you are hungry and you're freezing without shelter. Oh yeah, because you decided to continue. And so we check the constant answers to see what's happening here. And then we can set, you know, is user is alive equals false. This prevents the while loop from showing up into day 2 and day 3 from functioning. So we can quit the while loop, and at any one moment in any of the days we can kill the user essentially. In scenario number 2, we're going to print out you're inside of the jungle, which we saw before. Get the user input. This is all going to be the same code. And then we're going to check answer number 2 that says, is it equal to 1? If it is, go ahead and do all this stuff. So, health is minus 10. Else, health is plus 10. That's just how I accumulated 110 points at that stage, actually. And then print out something at the end. You fell asleep beneath the trees, and day 1's done, essentially. So at the end, it's always going to print out some result. If you're still alive at the end of the day, it's going to print this out. If you're not alive at the end of the day, your check for this is going to send you back. It's going to end the break. It's going to end the loop essentially. And day number 2 is going to look pretty much the same. You can read through it on your own to kind of get a feel for it. And then day number 3. So there's a beach in there too. You can actually get quite creative with this. Actually, I believe, if you wanted to. In terms of the print health, what we're doing is we're having, if health is larger than 0, then we're going to print out what your health is. And it's going to say you managed to finish the first day the total health is, and that's where I had the 110 printed out. And press any key to continue, and it's going to print out your name. your health of Barbara is blah, 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 blah. And then it's going to run our little function here. And then it's going to print the score at the end. And the score, we presented the number 36. So the score is going to be equal to x, 36 divided by 110 times 100. I guess it's so we don't end up with a 0 or something. So based on the health, you receive a certain percentage of the available points, and here are the points, essentially. And that's the functionality that's going to be printed out at the end of the scenario. So I like this example because it shows you how to logically organize things in terms of, and the most interesting part for me actually was this use of the extra function in there that was done in main. And we put the implementation up here in main. So it wasn't part of the object concept. But the object itself was the game. And so we didn't actually do anything outside of making instances of this object. In fact, we just made one because we had one game running. And then we made method calls to instructions and then method calls to day 1, day 2, day 3, day 4 to run kind of through a scenario. So it's just kind of like one design of an application that you can use as an approach for separating out the structure of the code. Now, this is an exchange of doing everything inside of main. You could write the same application and put everything inside of main. A little bit more confusing. So this kind of logical structure is a little bit more typical in terms of what you find with Objective-C and other object-oriented programs. So, all right, so that was the learning objective for today. What I'd like to do, and probably if I get the time to put this together for Wednesday, no promises, we're going to turn this into a GUI application. So I'd like to see it done that way. And that way you can see, well, how if I were going to make a command line prompt, that's how it's going to work. I'm going to take the same code, however, and see if I could put it in and show you as an example. So and then we'll move on to bigger and better concepts. But that, believe it or not, is everything I needed to cover for today. So we're done. So see you on Wednesday.